Radiation can affect the temperature measurement. Let's say we have gas flowing in a pipe and we want to measure the temperature of the fluid with the probe, with the thermometer or thermocouple. So this is, you have gas flowing and then there is this thermocouple here that we measure the temperature here. And let's say this is a temperature that's reading temperature of thermometer TTH. And let's assume the solid wall has the temperature of TS and the gas is flowing. And T, let's say the gas temperature, the true temperature is T infinity. So TTH is the temperature value measured by the thermometer in Kelvin, and T infinity is the actual temperature of fluid, again in Kelvin. Ts is the surface temperature of the solid, again that's in Kelvin. And let's assume H is the convective heat transfer coefficient around the thermometer surface, and that has a unit of watts per meters per Kelvin. Now, if the epsilon is the CDT of the sensor of the probe, sensor of the probe that we have, the thermometer that we have, in equilibrium conditions, what we have here is the heat transfer by radiation and by convections are going to balance out each other when we are reaching to the equilibrium, or Q convection is going to be equal to the Q radiation here. And if we write that H T infinity minus the probe temperature is going to be epsilon sigma T of probe temperature minus Ts to the power 4. So from here, the actual temperature of fluid would be what we are reading plus epsilon sigma over H T of Th to the power 4 Ts to the power 4. Now, to avoid the effect of this radiation from the surface of the, let's say this pipe could be higher or lower than T infinity, and based on that, we are reading different reading from the thermometer. Now, to avoid that one, either we coat, so the sensor, the probe sensor is coated with a material with high reflectivity, so we minimize the effect of radiation on the temperature measurement, or we are placing the sensor in a radiation shield. Exactly the same phenomena can happen, like we are feeling comfortable in a room at 22 degrees, so we can say, another example is we feel comfortable in a room at 22 degrees C when the walls are also at the same temperature. Now, if the walls are, let's say, 5 degrees C, then the interior temperature of the room should be raised to at least 27 degrees C to maintain the same level of comfort.